Hello, my name is Noah Geiger, and I'm going to do lab 3. We're going to start off with kind of some equations to know for this. We're going to be using the universal gravitational laws and then Newton's second law of momentum. This being, big M times small m times the g constant over r squared times the unit vector, and then the magnitude, of course, equaling just g over r squared. Newton's second law, we're going to do F net equals dp over dt. F net also equals F net perp plus F net parallel. Then we're going to be using the velocity update formula and the position update formula. All right, so let's kind of go into the code. So we start off with the GlowScript code here. Main places edit uh, here. So here we have our initial and final velocity vectors, and we just kind of set up everything so that the momentum is just the star times the initial velocity, and final is just the final uh, mass, which is just the same times the final velocity. So yeah, then we use it to find F net and all this other stuff, F parallel, F perpendicular, and such. And we're just going to run the program here to determine the mass of the black hole. As you can see, it's going, it's going, it's going. This kind of makes sense. Orange arrow is pointing directly in. That's F perp. Pink arrow is pointing kind of tangent. Can't see anymore, but that's F parallel. And then, of course, that orange is F net, the force. So combining all of these here, we can determine that the mass of the hole is 1.18 e to the 34th. And then from there, we can go to the second problem, where it asks us to find the ship, what's the initial velocity needed to escape, not only the gravity of the planet it's on, but also to make sure it doesn't crash into the black hole. So we're just going to input a kind of rounded number here. This is the massive black hole. We're not going to change these are constants. Then we're going to go down here. So these two digits right here, these are the things we're going to focus on, the initial speed in the x, the initial speed in the y direction. For these ones were a little bit difficult. It was mostly trial and error to my experience, not really figuring out how to calculate this per se. But yeah, so trial and error here. Uh, and I'm not gonna run it because it takes way too long. But you can see the pinkish purple line. That is the route the ship took. And you can see the closest it got was this distance, 1.93 e to the 10 meters away. So very far away. Things that make this stuff that could make this a little bit more accurate. I feel like since this was a computer thing, it was theoretically accurate. But just some things that could hint us some better numbers or just a little bit bigger time interval, more points equals more accuracy. I will say for this one, in the instructions, it did have, that's the first black hole, determine the mass. It was saying how the mass of the black hole should be different each time you run it. I wasn't exactly sure how they ascertained that because nothing in the code changed. So this was my number every time. So yeah, now that we have that. Big question is, what are the results? I got the initial velocity. So this ended up being my initial velocity of the ship, and the massive black hole right there. And now we have to go what does it all mean question. Um, how is the net force and its parallel and perpendicular components different from the rate of change of momentum and its parallel and perpendicular components? Momentum is mass times velocity, while as kind of perp for or net force perp is more acceleration going inward, and F net parallel is the velocity tangent to the circular motion. So they're just different, right? And of course, F net is the combination of those two. So it's just they're not exactly the same thing, but they can be used to determine anything you need to know. And then this what if statement is we're trying to orbit around the black hole, but like I said, after trying for a little bit, The best I couldn't figure out a way to calculate anything, so the best thing would be a guess and check here. And sadly, I just couldn't figure out exactly the digits of that. But yeah, that should be all.